Hello, we are going to take a look at chemical pathways and reaction mechanisms in this video. What I want you to do first is to pause and read through your document once over so you have a good idea of what's going on. It would also be good to maybe do the definitions of your vocabulary. They go on the flip side of the little foldy part. And then we'll go over some of the details and do an example from the next page. All right, so hopefully you have read through this. So we are looking at what are called reaction mechanisms, or a pathway for a reaction. So a pathway for a reaction would look something like these two steps. We call them the elementary steps. So each elementary step makes up the entire reaction. So there's some things that go on here. So if we look at elementary step 1, so they do go in an order, always step 1, then step 2. For this one, we can see hydrogen plus iodine chlorine. So we have two hydrogens, so a hydrogen molecule, and then our iodine would be our larger one, so Cl and I. So those two things, when they collide with each other, they react and they form HI. So this is our HI, and we get HCl. So we get two new products. Then those products collide a second time, or excuse me, not both products, sorry, the HI comes down here. So this is our HI. Look at my reaction more. That comes down here and reacts with a second ICl, and we get two more products. So we get iodine, I2, so that's this one, and we get another HCl from that. So we've got the hydrogen reacting with this to form our two products, then one of those products reacting again with another ICl to form I2 and HCl. So there's a question posed over here. Does anything cancel? So when we look at this, if we want to cancel something, they need to be on opposite sides to cancel, okay? So we can see that HI is a product of the first reaction. We make it. We call that an intermediate. And that's mentioned down here. So HI is referred to as a reaction intermediate. We take that intermediate because it's made in the middle, and then we react it again down here. So what happens with an intermediate is that those can cancel with each other. They're on opposite sides, so intermediates will cancel out. It's something we make and then we use up. So when we look at our overall reaction, there's nothing else that does that. So we get hydrogen, we get two iodine chlorine, so we add those together, we get two of them, so we put a coefficient in front. We get iodine, I2, and then we make two HCl molecules. So this HI is our intermediate, and that's the part that cancels out. And the rest of this is what's left in our, is our reaction, our overall reaction. Okay, now it mentions down here that these multi-step reactions can occur at different speeds, and this is where it comes into this reaction rates unit. The overall reaction speed is limited to the slowest elementary step. So the slow step determines the rate of the reaction. The whole rate of the entire reaction, everything together, is determined by which step is slower. So it says, think of it like a relay race. The overall team is only as fast as the slowest member. The rate at which a reaction occurred is only as fast as the slowest elementary step. That is called the rate determining step. Okay, a rate determining step is always our slow step of our reaction. So this one is not labeled as fast or slow, but when we get into the practice, we'll see that the steps are labeled there. All right, now one thing that's not mentioned or shown in this reaction is a catalyst. We've talked about catalyst being something we can add to the reaction in order to make the reaction speed up, go faster, and it creates a different pathway. So it would alter the pathway of the reaction. Now, it will appear in the reactants of the first reaction, okay, and the products of the last reaction. Okay, so we'll have reactant making products in a first step. We'll have another reactant making products in the second step. Our catalyst will be on this side and then this side. Okay, so we'll start with it and we'll end with it. Catalysts don't get used up during the reaction. They just help along the path. So they help you get through it, and then it'll pop out at the end again. Okay, so it's like a boat carrying you to the end of the course here, right? It's still going to be there in the same form at the end, but it's going to help along. They are different from intermediates because they appear as a reactant at the beginning and are not made in the process. Not made in the process. We put them in, okay? An intermediate we can't put in because it's made by the reaction and used by the reaction. But a catalyst we can add to the reaction. So we've got down at the bottom our 4 words, 4 vocabulary terms. So the elementary step, the catalyst, the intermediate, and the rate determining step. Those are new terms for us. And those, we're doing a picture on the front and then their definition on the back. You can do that on your notebook paper underneath them or on the back of the paper here. So what are we doing with this? Well, for a reaction mechanism or these multiple steps, what we want to be able to identify are any intermediates that we have, identify which step 1 or 2 or 3 if there's a third step, is the rate determining step, find any catalysts if they are there. Not every reaction will have a catalyst, and then be also able to write the overall reaction. Okay, those are our goals. So when we look at this reaction, the first thing I like to find is my rate determining step. Okay, that's identified by the slow step. So my first step is the rate determining step. And then I want to find any intermediates I might have. So I'm going to start by looking on the right side of the first reaction, my products, and then seeing if any of those chemicals repeat as reactions or as reactants in a later step. We can see that the NO3 repeats, so that's my intermediate. That will cancel. I'm also going to go ahead and look for any catalysts. So catalysts are chemicals that we start with as a reactant and we end with as a product. So I'm going to use a different color so we can see the difference in our catalysts versus our intermediates. Let's see if we can see this color. All right, so in this case we've got NO2 and NO2. Those two are the same. I know we have 2 of them. You could look at either. So we're adding extra NO2 basically as a catalyst here. So we do have that. We can list that and we can go ahead and cancel just one of them as our intermediate or as our catalyst, excuse me. And then we want to add the 2 reactions together to create our overall reaction. So anything on the left of the arrow is going to stay on the left. I have 1 NO2 and I have 1 CO. And then we're going to put our stuff on the right. On the right, we have 1 NO and 1 CO2. So we can see the overall reaction, what's happening is this oxygen is being transferred to the carbon monoxide. But to do that, to facilitate that process, we need this extra NO2 to provide that pathway. We've got to take an O from our NO, make this unstable thing, and then that will react with the CO so that the reaction will actually occur. Without that catalyst, it wouldn't be fast enough. We wouldn't have that enough activation energy to make it work. So we lower the activation energy by adding that catalyst, and then this reaction can happen. Okay, so that's our process, what we want to look for. So again, intermediates are a product first and a reactant after. Catalyst is a reactant first and a product at the end. Okay. So you've got some practice for that, and that's it. All right, try those out and let me know if you have questions. Thanks, guys.